This SciShow space video is sponsored by Morning Brew. Morning Brew is a free daily newsletter Monday through Sunday that gets you up to speed on business news in just 5 minutes. Click on the link in the description to subscribe now. In the 1970s, astronomers discovered a bunch of gamma rays that stumped them for almost 20 years. The light was spotted by NASA's second Small Astronomy Satellite, or SAS-2, which scanned the sky for gamma rays in 1972 and 73. These rays have the most energy of any kind of light, and they come from the most extreme stuff in the universe, like neutron stars and matter around black holes. So pretty quickly, astronomers figured out which objects made most of the light the satellite detected, except for one spot. It is elegantly called 2CG195+04, but it's nicknamed Geminga, and 50 years later, it still has not revealed all of its secrets. The name Geminga is actually very good. It's somewhere between pun and acronym. It is near the constellation Gemini, and it emits gamma rays, so scientists squashed those words together to get Geminga, which is also similar to a phrase in the Milanese dialect of Italian that means it's not there, or it doesn't exist, which is appropriate, because when astronomers tried to learn more about it, they came up largely empty-handed. They did find X-rays in the same area where the SAS-2 satellite detected the gamma rays, but neither measurement could pin down an exact position, so scientists couldn't be sure that all that high-energy light came from the same source. And when they checked this region in other kinds of light, they couldn't see anything. There was no visible light, and weirdest of all, no radio waves. That's especially confusing considering that the most likely culprit for this light was a pulsar. Pulsars are a type of neutron star. They're super hot, dense remnants left behind after massive stars explode, and they are the most common object in space that gives off gamma and X-rays. But as pulsars rotate, they also send pulses of radio waves in our direction, especially from around their magnetic poles. And since the researchers didn't detect any radio waves near Geminga, what was this thing? Astronomers throughout the 1970s and 80s proposed all sorts of ideas for what might be going on. But the first real breakthrough did not come until 1987, when a pair of scientists found a tiny blip of a star in the same region as the gamma and X-rays. It was 40 million times dimmer than anything you could see with the naked eye, but it was the start of a decade-long bonanza. By 2000, teams around the world had proved that the gamma rays, X-rays, and that tiny star's visible light all waxed and waned about 4 times a second. With that many similarities, these kinds of light had to be from the same source, and that source had to be a pulsar. After all, that waxing and waning suggested the star was spinning, and anything bigger than a pulsar could not spin that fast. Also, anything less extreme wouldn't make gamma rays. But Geminga sure is an odd pulsar. For one, it is really old, considering how many gamma rays it emits. Neutron stars spin slower as they age, and spinning around 4 times a second puts Geminga around 300,000 years old. Other pulsars that emit similar levels of gamma rays are only a couple thousand years old. Still, that age could help explain why it's so dim in visible light, since neutron stars also cool off as they get older. But this doesn't explain the radio silence. One popular idea is that Geminga's magnetic field is so intense that when particles travel along its magnetic field lines and smash together, these collisions produce a shower of subatomic particles, and that shower absorbs radio waves near the star, almost like a cloaking device. Astronomers have also calculated that for a lot of pulsars, the cone of gamma ray light they send out from their poles is naturally wider than the cone of radio waves. So maybe we're just not at the right angle to see Geminga's radio pulses. Either way, this radio mystery continues to fascinate astronomers just like it has for 50 years. And even though we have not cracked the case yet, Geminga has been teaching us about the universe in other ways. It even resolved what seemed like an unrelated mystery. In the early 2000s, scientists were detecting way more high-energy particles than they expected, specifically electrons and their antimatter counterparts called positrons. It can be hard to find where these particles come from because they don't travel in straight lines. Magnetic fields in the galaxy twist their paths all over the place. So some physicists wondered if these particles could be evidence of dark matter interacting with interstellar dust somehow. Dark matter is that invisible kind of matter scientists are just beginning to understand, and if it was influencing these high-energy particles, we could learn a lot about it. But it wasn't dark matter. It was Geminga. Turns out electrons and positrons are the same particles that produce a lot of Geminga's gamma rays, and this pulsar has been tossing them into space for hundreds of thousands of years. And since this object is pretty close by, a lot of them go on a twisty journey and then end up right here on Earth. And even though they don't come straight from their source to us, instruments have found that there's a big cloud of positrons around Geminga that's about as wide as the Big Dipper we see in the sky. So Geminga continues to be a mystery. Even half a century later, astronomers have not been able to answer one of the first questions they had about this object. But along the way, this weird ancient pulsar is still teaching us more about the complex universe we live in. Thanks for learning about cool space technology with SciShow Space. If you want to hear about tech news in the mornings, you can check out this video's sponsor, Morning Brew. They provide free daily updates on tech, business, entertainment, and more in a witty, relevant, and informative newsletter. In just 5 minutes, you'll be up to speed on all the need-to-know information, with some games thrown in too. So I highly suggest, instead of doom scrolling, you can start your day with a jolt of crosswords and accessible news. One of their recent articles, Tech Companies Are Racing to Crack the Code of Marijuana Testing, discussed the new technology being designed for drug testing. According to Morning Brew, this technology could provide a more specific time frame for when the compounds were in your body. So you can let those innovations get you going in the morning by reading Morning Brew. Subscribing is completely free, and it takes less than 15 seconds. So you can click on the link in the description below to subscribe to Morning Brew today.